Hey everybody, I want to show you how I solve stoichiometry problems, and I'm going to post this practice worksheet and a couple others for you to work on if you want to. Never going to be graded, never going to be turned in or anything like that. It's just some extra practice for you. And when I think about stoichiometry, I always follow these 5 steps at the top. Step 1, you're going to write a balanced chemical reaction. Step 2, you're going to calculate your starting material in number of moles. Step 3, you're going to identify the limiting reactant. Step 4, you're going to subtract the limiting reactant from the reactant side and add the limiting reactant to the product side. Step 5, you're going to calculate how much product you make and how much excess reactant you have. And I'm really going to do this just for these first 2 problems. So take a moment, read through them, and we'll get started on the board in just a moment. Okay, so for this first problem, we are mixing magnesium nitrate and sodium sulfide. It's a precipitation reaction. I think those are the best for kind of getting started with limiting reactants because you have a really obvious product. Step 1, balanced chemical reaction. You're going to have magnesium nitrate plus sodium sulfide goes to magnesium sulfide plus sodium nitrate. Oh, I should have given myself more space. Of course, if we have a balanced chemical reaction, we first have to make sure we've got everything charge balanced. On the periodic table, magnesium's a +2, so I'm going to need 2 of my -1 nitrates. Sodium's a +1, so I'm going to need 2 of those to balance with the sulfide. I also should always include states of matter. And I know that these are both aqueous because nitrates are always aqueous. Sodium compounds are always aqueous. This sodium nitrate, we're going to have a 2 there. That's also going to be aqueous, and this is going to be solid. And I think with that 2 there, we've got a magnesium and a magnesium, sulfur, sulfur, 2 nitrates, 2 nitrates, 2 sodiums, 2 sodiums. So we're balanced. We're going to take magnesium nitrate, and we're going to take 122 milliliters at 0.444 moles per liter. And you'll notice I'm always really careful with my units on the moles because with 4 different compounds, it's really easy to lose track of which thing you're looking at. This problem is going to be pretty straightforward because we're going to be looking at mostly just the 1-to-1 ratios. So our mole ratio is not going to be particularly tricky here. We'll calculate the moles of magnesium nitrate. This is just going to be a multiplication dividing by 1,000 milliliters per liter. This will get us into canceling out liters and just getting us a number of moles. And we're mixing with that 103 milliliters of 0.321 molar sodium sulfide, which is 0.321 moles of sodium sulfide for every 1 liter. Again, converting to liters. We plug that into our calculator. And for this number, I already did the calculation on a separate piece of paper. I'm not that fast. 0.542 moles of magnesium nitrate and 0.0331 moles sodium sulfide. So that's our amount of starting material. And I'm going to rearrange things a little bit just so I've got more space. I'm going to write these number of moles right below the compounds just so I've got a little bit more space. 0.0331 moles and 0.0542 moles. And I let myself get a little bit sloppy with my units. When I've got it written right underneath it, I know that this is moles of sodium sulfide because it's pretty much labeled by the chemical reaction. Now, for something where we've got a 1-to-1 mole ratio, so we've done step 1, step 2, we've got our amount of starting material, and we've got our balanced chemical reaction. I like to think of the chemical reaction as the recipe for what's going to be put together, and the number of moles as the starting amount of ingredients. And the question becomes, well, which ingredient are we going to run out of first? Very similar to what you saw in Dr. Neff's video with the sandwich example. What's going to run out first? For these situations where we've got a 1-to-1 mole ratio, it's going to be the smaller number. Right? Typically, and we'll see this in the next example, we have to do a little bit more logical thinking to figure out which one's going to run out first. But with a 1-to-1 ratio, the smaller one's going to run out first. So let's go ahead and subtract our limiting reactant after we identify this. Again, I like labels, so I'll label that as a limiting reactant. I'm going to subtract my limiting reactant from the reactant side and add it to the product side. Essentially, this is going to determine how many times we finish the recipe. And we're going to figure out how much of our other ingredient we have left over and how much of our product we make. Yeah, we'll do that. Okay, so we're going to have 0.0542 moles magnesium nitrate minus 0.0331 moles sodium sulfide. And you'll notice these units don't match up, so even though it's mathematically boring, I'll include my 1 mole magnesium nitrate for every 1 mole sodium sulfide. I include my mole ratio. In this case, even though it's boring, I'm just multiplying by 1 mathematically. But in terms of unit analysis, and what I say is in terms chemically, what we're doing is we're using our chemical reaction, our recipe, to figure out how much ingredients we're going to be using for our other compounds. So this allows us to change which component we're thinking about. Now this is going to be moles of magnesium nitrate minus moles of magnesium nitrate, and that will give us how much magnesium nitrate is left over. Oh, math is hard, even when you already have the answers. Moles. And just so I don't lose track, I like to label it as moles of magnesium nitrate excess. We'll do the same thing for the amount of magnesium sulfide produced. Now, we didn't start with any magnesium sulfide, and in this class we're never going to, but in Chem 125, 128, you'll have situations where you have non-zeros in your products. Don't worry about that this quarter, but if you're wondering why I'm starting with a 0 moles magnesium sulfide, that's because we don't have any magnesium sulfide at the start. And we're going to add to our product side, so that's going to be plus. Same thing, 0.0331 moles sodium sulfide, multiply by 1 mole magnesium sulfide for every 1 mole sodium sulfide. I'll mention a couple things that are nice to know here. First off, we're using multiply by 1. We've got our 1-to-1 mole ratio, our 1-to-1 mole ratio, 1-to-1, 1-to-1. That part's mathematically boring. For our molar ratios, when we're doing stoichiometry, the coefficient of our limiting reactant always ends up on bottom, because that's the thing we're always switching from to talking about the other components in the reaction. Really mathematically easy step there. We get 0.0331 0.0331 moles magnesium sulfide produced. It also asks us to get that in terms of the number of grams. So we'll multiply by the 57.01 grams magnesium sulfide for 1 mole magnesium sulfide, which will get us 1.88 grams magnesium sulfide. So for problem 1 on that practice problem, there are 3 things it was asking for. It was asking for the amount of excess, it was asking for the moles of product, and the grams of product. So there's our 3 answers. I just decided I'm going to quickly show you the way I like to organize my math. As you know, you can do mathematics like, you can do 1 plus 12 plus 138, or you can do 1 plus 12 plus 138, and you can do math this way and equals, or you can do math in a column. And the benefits of doing the column math is you start to line things up in a favorable way. You're lining up all your 1's digits, your 10 digits, your 100 digits. We can actually do the same thing with our stoichiometry. So instead of having my mathematics written across, and you don't have to do this, if you're comfortable with this way, do it that way. I like the organizational aspects of doing it in columns underneath the components I'm talking about. And it's also something useful in later chemistry classes. So if you're planning on taking a bunch more chemistry classes, this might be useful to you. So I'm going to take this mathematical expression of the 0.542 minus 0.0331 moles times a 1-to-1 mole ratio. And then I can do that math straight down. I'm going to have 0.0331 minus 0.0331. That's going to give me 0. The limiting reactant is always going to end up with 0 reactant left over. We're going to have 0 plus 0.0331 times a 1-to-1 ratio. That's going to get our magnesium sulfide. And we can even, very quickly now, do the spectator ions, even though nothing in the problem asks us to do that. And what I like about doing it this way is you're essentially just condensing your units, because now everything in this column, as long as you got your mole ratios, about magnesium nitrate. Everything in this column is about sodium sulfide. Everything here is magnesium sulfide. You've got your subtraction on your reactant side, your addition on your product side. And I like to think about it as where you start, what happens during the reaction, and what you get at the end of the reaction is what's down here. 0.0211 moles and 0.0331 moles. I find this math that I just put up here in blue, it's exactly the same, right? I do better organizing my thoughts like this. Now, with this, you notice it takes up a lot less space, it's all organized. Practice the long way a couple times. If you're not terribly comfortable with stoichiometry, practice the long way first. Get comfortable with it, because you'll notice in this condensed way of writing it down, it's really easy to lose track of your mole ratios, which things you're adding, which things you're subtracting. So make sure you've got some practice there. Problem 2 is a little bit more interesting. So if you don't remember problem 2, pause the video. Here, let's just show you real quick. So in problem 2, we're mixing magnesium nitrate with sodium phosphate. This is not going to have a 1-to-1 ratio, so we're going to have to do a couple extra steps in order to get it. I'll leave that up while I make the chemical reaction. Okay, so again, we've got magnesium nitrate, same thing. This time we're adding sodium phosphate to it. we're going to end up making magnesium phosphate. And sodium nitrate. I miss the classroom whiteboards. They're a little bit longer. I can fit more stuff in there. Solid. Okay, so I went ahead. I already charge balanced these things. +2 -1 twice, +3 +1 3 times, -3. The 3, 2 balancing, this is going to be a -6, that's a +6. Our balancing coefficients will end up being 3, 2, 1, 6. We're going to go ahead, we're going to calculate the amount of each compound. Again, this is just solutions, this isn't using solids, so it's just going to be volume times molarity, volume times molarity. So, first one is 0.022 liters. I did the conversion from milliliters to liters quickly in my head, times 2.24. And for this one, it's going to be 0.0103 times 3.33. And that's going to give us our moles of each component. That's going to give us 0.04928 moles here, and 0.0343 moles here. Again, this is going to be moles sodium phosphate, and this is going to be moles magnesium nitrate. I'm using the organization under columns, but I want to be a little bit more explicit with our units here for a moment. So one of the problems we have now is we don't have a 1-to-1 ratio, so we have to be a little bit more thoughtful about which ingredient is going to run out first. There's several different ways in order to calculate which ingredient is going to run out first. You can do it by inspection and just kind of relatively get a hunch. You can guess. If you guess wrong, you end up with a negative amount of reactant, and if you ever end up with a negative amount at the end, you've done it wrong. Switch which thing you've had. That's not the best way to do it either. The way I've taken to liking it the most these days is by doing a moles of reaction calculation. So what I mean is, and this is kind of a separate thing from the rest of mathematics, which is why I'm boxing it off in the corner. After we figure out what the limiting reactant is, we'll kind of ignore this math. I know I need 3 magnesium nitrates for every time we complete the reaction, so I can say 0.04928 moles magnesium nitrate times 1 reaction needs 3 moles. And I can do the same calculation for the sodium phosphate. This will essentially tell me how many, this will tell me how many times I can complete the reaction if magnesium nitrate was my limiting component. And then I can do the same thing with my sodium phosphate, 0.0343. Here, 1 reaction needs 2 moles. And I'm going to figure out whichever one is bigger, that is to say, or whichever one is less, whichever one has the fewer number of times we can complete the reaction, that's going to be the thing that limits how many times we complete the reaction. So I'll do 0.04928 divided by 3. This says that I'm going to complete the reaction 0.1642 mole times, right? Times 10 to the 6.02 times 10 to the 23rd. And if I do the same calculation here, 0.0343 divided by 2, 0.01715 reactions. So it turns out, because of the mole ratio, the smaller number actually ends up being in excess. Now, it's not because it's the smaller number. It's just showing that we also have to take into account our recipe. It's not just how much ingredients you start with, it's the recipe you're doing as well. So in this situation, the smaller number, that's going to be my limiting reactant. So this is my limiting reactant. After I get that limiting reactant figured out, we could use this number for like a moles reaction type step, but I find it confusing from the rest of it. So I'm just going to ignore all that for a moment, and you'll see where it kind of like crops up where we could think about it, but I like to try to keep things as simple as possible. So after identifying my limiting reactant, now I'm just going to go back to the regular steps I did last time. I'm going to do it long ways again, just because we're getting used to it. We'll calculate how much excess reactant we have, so it's going to be 0.0343 moles sodium phosphate minus 0.04928 moles magnesium nitrate. And clearly, if this was it, we'd have a mistake because that's going to be a negative number. But we have to remember our mole ratio, right? Our units aren't matching. Magnesium nitrate, sodium phosphate, those are different compounds. So multiplying by my mole ratio, I'm going to need 3 moles magnesium nitrate for every 2 moles. Sorry, I just did it backwards. And it happens to everyone, right? As soon as I started writing my next thing, I realized, hey, that's not going to cancel out. This is a good reminder. The limiting reactants coefficient should be on bottom. So check your units. If I just did this the quick way, I might have made a really horrible mistake right there. So writing out our units helps. I want to change from magnesium nitrate to sodium phosphate, so 3 moles. Magnesium nitrate goes up the bottom. I got carried away, I'll admit it. I was like, oh, first thing goes on top. No, make sure you're paying attention to your units. And then the 2 moles sodium phosphate goes on top. Right, and you can see where this 0.04928 divided by 3 will give us how many times we complete the reaction, times 2 will give us how much of the magnesium nitrate we don't use. Sorry, I keep saying magnesium nitrate. I blame that last problem. Sodium phosphate we don't use. So 0.0343 minus 0.04928 times 2/3. And that will give us 0.00145 moles. That gives us our excess amount of material. If we did the same calculation for magnesium nitrate, we're going to end up with 0 moles of magnesium nitrate excess. That's the definition of the limiting reactant. You have 0 moles of it left over. We can go ahead and calculate the amount of magnesium phosphate we're going to make as well. Starting with 0 moles, because we didn't have any at the beginning. And again, don't worry about the 0 moles. It's just to keep, I like it to keep my units straight, and again, it comes in handy in future classes. 0.0 moles magnesium phosphate. Since this is on the product side, we'll be adding our limiting reactant. It's how many times we make this product. 0.04928 moles. Magnesium phosphate. Mole ratio in this case is a 1 to 3, 1 mole of magnesium phosphate for every 3 moles magnesium nitrate. Got it right that time. Even though I wrote the wrong thing. So we can do 0 plus 0.04928 times 1/3, and that will get us 0.01643. And so that's our sodium phosphate excess, our magnesium phosphate made, multiplied by the mole ratio to get the grams. And that's how I do stoichiometry. Write a balanced chemical reaction, identify the limiting, calculate the moles of starting material, identify the limiting reactant, subtract the limiting reactant from the reactant side, add the limiting reactant to the product side with mole ratios, of course, and then calculate. Let me go ahead and show you what this looks like if we do it in the condensed way that I like. So we're going to start with these numbers in blue, which I call the start. Our reaction will be subtract limiting reactant from everything, 0.04, sorry, from a reactant side, 4928 times 3 to 3. Minus 0.04928 times 2 to 3. Notice coefficient of limiting reactants on bottom. Plus 0.04928 times 1 to 3. And we can do this one as well. 0.04928 scrunched in the corner, 6 to 3. Now this last one doesn't matter. There's nothing in the question about it. And then we can go ahead and do our mathematics straight down. We've got our moles of limiting reactant, mole ratio, moles of limiting reactant, mole ratio, moles of limiting reactant, mole ratio, moles of limiting reactant, mole ratio. In each of these cases, you can see how you kind of get that moles of reaction complete. 0.04928 divided by 3 is everywhere. So we still have that idea, but I like doing it this way just so I don't lose track. Of course, our limiting reactant ends up with 0 moles of excess. That's the definition of limiting reactant. It runs out. This one is our 0.00145 moles excess, and our 0.0163 moles produced. Again, I'm not doing the last one because there's no questions about it. It's so nice to me to do it that way. Keep working on the worksheets. The way you get quicker at this, the way that you get better at it is just practice. Come to office hours. I'll be happy to answer your questions.